That was Cat Stevens and Morning Unbroken. Morning Broken. Morning has broken. I've got some words in there. Morning, broken, has broken, not unbroken. Okay, a broken morning. It's not a broken morning, it's an unbroken morning. At any rate, Cat Stevens. We have had, of course, a test on formulas. And as I was just sharing with the folks in here, it went very well. We had very strong performance, over 30%, 35% of the grades at B or higher. So that was really impressive. And if you haven't taken that test, you need to see me. We need to get that done so I can return the test tomorrow so you can figure out how you're feeling. And I'll be happy to share some grades with you at the end of the hour so you can see how things went. And we also have the midterm that I'll try to get out to you. I just didn't know where it was quickly to see that. So I'll share some papers at the end. Well, I know, but some of them is. Some of them are. That's not the right stack if I remember correctly. So, at this point, new unit, how much? So it's unit 3. So we're going to talk about that. Not too much. How much? You're going to lose a grade right there, I can tell. Okay, here is the title. It's on page 59. So it's how much?
I actually started reading it.
Very good. Let me talk about this unit a little bit because the title of this unit came from, well, first, where did the unit itself come from? Let me put that in some perspective. This was a unit that was requested. Now, when I started writing the materials, and this went through several different versions, this particular book was more a result of student request than anything else, because they were saying, could we have a unit just on word problems that would help with that? And this unit originally came out of a course I was teaching along with another faculty member, the RN program and the LVM program here in college. Students have to take what they call a state board examination. And in the state board, they needed to know dosage problems. And there are a couple of ways of dealing with dosage problems. So for example, you know that although aspirin is now not recommended for children, at one point a typical dosage for a child was half an adult dosage. And so you made adjustments for the amount of aspirin you gave. Again, a reminder, you do not give aspirin to children because there are problems potentially doing that. Now, second relationship to this problem. 1967, just to put some things in perspective, versus 2006. In the last 24 hours, what has been on the news about 1967 versus 2006? You haven't been watching the news broadcast. You've been doing your homework, I know.
The statistics of, my husband was saying something about how many people there are.
Yes, it is. It is the population growth. 1967, 200 million people. 200 million in United States. 1967. Today, yesterday to be exact, 4:30 morning, New York time.
A child was born and made it like 300.
The argument was, instead of the New Year's baby, it was the 300 millionth child. Okay, and so we had 300 million people celebrated yesterday. And the argument is, if we continue that rate of growth, by 2043, there will be 400 million. And so 1967 was a period of time, 200 million. What happened in 69? That's related, another very important event in 1969.
Baby boom.
No, the baby boom started a lot earlier than that. 1969, we walked on the moon. That was the infamous moonwalk, other than Michael Jackson's version. Okay, so 1969. Well, there was another event that occurred in 1969, which was the birth of one of my kids. And 1969, I was in a hospital. About the same time the moonwalk was going, because during the moonwalk, I was carrying around this young boy who was up chucking every time we fed him anything. So give a bottle, put him on your shoulder, and then everything over your back on the floor. And it was called pyloric stenosis, which means that there's a pyloric valve that doesn't work right, it closes off, and so that meant surgery. So here you have a 6-week-old baby in the hospital with surgery. And I remember an argument going on at the nursing station about what would be the appropriate dosage for a 6-month-old child. And it upset me. So I did an explanation about the mathematics of what needed to be done. And I don't think it was appreciated. But that was very much the start of this unit, because there was a song that was also popular somewhere about 1970s when I was writing this material originally in the early 70s, and it was by Peggy Lee. How much is that doggy in the window? And you hear it occasionally. But how much sort of stuck in my head, so that became the title of this unit. Now, this unit, when we were doing it in the nursing program, was given a different name. And we're going to cut to the board now, and I've left some things on the board just to see how this works. We called it dimensional analysis. That's a fancy name, and it's just used in science. Now, what's more important is what I have here at the bottom, proportional thinking. Now, much of my background, besides being in mathematics, is also in the field of psychology. And so some of my doctoral work was with the way intellectual development occurs, and it was through the work of Piaget. Proportional thinking is the kind of thing that most of us do on a daily basis. So for example, let me give you just, you're out driving on the freeway, and you're going down, oh, let's say, I-5, but not the stretch where you can go 80 miles an hour. So it's more of commute traffic, and so you're traveling about 50 miles an hour, and you hope you can average that. And you know you have to go 200 miles. How long is it going to take you? 50 miles an hour, and you're going 200 miles. How many?
2 hours.
50 miles per hour. And 2 hours, how far will you go if you're going 50 per hour?
Isn't it like 40 hours?
No, not 40 hours. Let's try again.
4 hours.
If you're doing 50 miles per hour,
2 hours.
2 hours would take you 100 miles. So 4 hours would take you 200 miles. Right?
Oh,
50 miles per hour. You have a 200-mile trip.
200. I put 100. Sorry.
200 miles. 4 hours makes sense? Now that's proportional thinking. Let's do another one. I have a problem on the board as we go to there. This is related to when you are buying vegetables, fruit, and so on. And so the problem I was talking about here was you go to a store and you find something like oranges, 2 pounds for $1. And you want to get 6 pounds. Does it make sense you're going to get $3? You have to pay that much? So if it's 2 pounds for $1, 6 pounds is 3 times as much here, so you pay 3 times as much here, $3. That's proportional thinking. Okay. And we learn to do that. Now, just a comment, you typically, as a child, can't do that. If you think of doing proportional thinking as a child, 4 or 5 years old, not going to happen. Most development puts you at about 11 to 13 before you do well with proportional thinking. And it's something you can easily get frustrated on, and with stress, it can go right out the window. Okay? And that's the problem. On the state board exams for the nursing students, to do proportional thought in some of the problems, it was just too awkward to do, and they had trouble with it. So what we're going to do is look at the kind of problem that's much more difficult, and I'll show you how we treat it from early Greek mathematics up through an algebra class. And then we're going to do it in a different form. So back to the board. Here's a problem that is, okay, didn't telegraph adequately for Debbie. This problem here, 2 pounds for $1.50, and you weigh the oranges you have in the scale, and you find it's 5.5 pounds. I can't sit there in my head and do this problem well. I can estimate it. Okay, I can say 4 pounds is $3, right? Okay, and then I have another pound on top of that, so it's like another 75 cents, and I can sort of break it up into little pieces, but just to say it comes out exactly at a certain number, not going to happen. Close. Now, I'm going to go to Greek mathematics. Now remember, they didn't have the symbols that we use for numbers, so they wouldn't write a 2 and a 5.5 like we have. They would use other symbols. They didn't have an equal sign, okay, so they couldn't use equals. And they wrote it as what we call a proportion. Proportional thinking, proportions. So we slide over. Are you familiar with what we call odds or gear ratios, 3 to 1, or your odds are 50 to 50, meaning you have a 50% chance? Well, if we look at this, you say 2 is to $1.50, so I just wrote it as 1.5. And let's bring that in a little bit tighter if we could there, Debbie, just so it makes it a little bit easier to read. Thank you. 2 is to 1.5 as 5.5 is to some number. So this was 2 pounds for $1.50, so 2 is related to this as 5.5 should be to the number I need. Now, in modern day, we say we have 2 over 1.5, 5.5 over what I'm hunting for. Now, notice I wrote up here means and extremes. And that's what the Greeks actually used as the words. The middle part and the extreme part. So you had the part inside and then out. The extremes become the out, and the middle become the means. And they said this. Now we can drop down just to here. They said, the product of those means will be what? What do I have written? The product of the extremes. Okay? So if I look, again, just going up a little bit, here are my means. So that says 1.5 times 5.5 should be what? 2 times the question mark. So that says that if I take this 2 times this, it should equal 1.5 times this. Now we actually have a phrase for that in algebra. We call it a cross multiplication, just like you cross cancel. So your cross product this way is equal to this cross product. Now I'm going to set it up. We're going to move a little bit more to the right because I'm going to take this same result, but I'm going to replace the question mark with x. So coming over now. And I've shown you the cross product. And again, let's bring that in a little bit tighter first at the top, Debbie. This is low-tech PowerPoint, is what we've decided to call this, meaning I have. Now, in here, the cross product means 2 times x is 1.5 times 5.5. And that's actually an algebra problem. Now, I'm going to block this off for a moment. You can see the products. 2x is 1.5 times 5.5. And notice I didn't use an x here for multiplication. I just have in parentheses, 2 parentheses next to each other mean multiply. So again, I'm blocking off what I had done here. You have 2x equals whatever that mess is. I only want 1x, so I divide both sides by 2. And here's what I get. 1.5 times 5.5 over 2. Now, do you have a calculator with you? If you do, pull it out. Let's see what we can get out of this. This is the point in the semester where we start thinking about using calculators, so you might want to start bringing them with you. So I have 1.5 times 5.5 divided by 2. Let's see if you can get the number. I'm blocking it for you, I hope, so you can't see it very well, what you're going to get at the end. Okay, you're saying what now? 4.125 is what I'm being given as a value. So let me slide out of the way. And the 4.125, you would get charged $4.13. Okay? Now that is referred to as solving a proportion in algebra. So we call this a proportion. So this is solving a proportion. In algebra. And we actually have a whole section of problems in Math 70 doing exactly what I did there. So that's a Math 70 lecture for that part. Now, proportional thought can be done just by doing the same kind of thing where I said 2 pounds for $1, 6 pounds, $3. You just do it in your head. That's much more difficult to do as the numbers get different, as they get difficult. And so we resort to this. Now, there are certain problems that get just difficult enough that you can't do that way. Okay, and that's what we're going to now look at, which is also part of the science curriculum, part of an algebra curriculum, and the pre-algebra curriculum. So what I'm going to cover in this unit, called dimensional analysis, is exactly what you would do in a Math 20 class. You'd be expected to do it in a chemistry class, physics class, a class in earth science, a class in biology. It's called dimensional analysis. So at the moment, I'm going to go back to the document cam and remind you that this unit is called How Much, and that the kind of problems we're doing are going to involve the same idea. So as we come off there for a moment, Debbie, and then that'll give you a chance to free up, but let's come back to me. As we think in terms of the problems in this unit, I'm on page 59, but I'm going to move away from there for a moment and just try to get to something that we can relate to. Let's see. Page 71. This is one that just amused me because it's problem 8. We'll just see how the directions read in something like this. You're going to use dimensional analysis. That's the process we're going to use. And this is a typical kind of problem that would be a little bit hard to do in your head, but still you might be able to do it. A small package of tea. It's called a tea bag, right? And you usually, if you want to get tea at the student center, I think they hand you a tea bag, and you get a cup, and you fill it with hot water. Now, how much do they charge you for that tea bag? I'm estimating here that it might be 75 cents. Does anybody know the price of a tea bag?
I know a box of tea.
No, but I'm just talking about that little tea bag that you can buy if you want tea. If you go to a restaurant and you want a cup of tea, I think it's about as expensive as a cup of coffee. So my guess is probably $1, $1.50. And if it's really upscale, $5 for the tea. And they have that little tea bag. Yes, for the tea bag. And they'll pour the hot water for you, though. But they want a tip for it. So in terms of a bag of tea, Jeff, I doubt you ever serve tea, right? You do? You know what the price is that you charge for the tea bag?
About the same as coffee.
And the coffee would be?
$1.50.
$1.50. Okay, that's what I was thinking about that. Now, as I say, if you get to a place, if you're in New York at one of the really upscale restaurants, my guess is they bring the little coffee urn to the table, and it'll pour about 3 cups, and that's going to run you probably $5, $6, $7 for the coffee. Yes, I agree. Ouch. That is riding bulls. Now, in terms of this, if we go ahead and we talk about how much would a pound cost you, and I need to have you understand that some teas are very expensive. One of my colleagues is from China, and he said that sometimes tea can run in the hundreds of dollars a pound. Some of the tea is extremely expensive. So the Lipton tea I get isn't very high quality compared to, I wouldn't pay $100 a box.
Maybe it's stash.
What is it called?
Stash tea.
Stash tea?
Mm-hmm. That's good.
And how much is it?
It's like $5 a box.
$500. Well, this,
16 bags.
okay, for 16 bags. Okay, so this up around 50 cents a bag, a little bit less than that, more like 35 cents a bag. So my question, how would you do a problem like that? Well, that's what this is about. So I'm going to go over to the sideboard and share with you a problem that happened some years back at about this time of the year. Now, what's happening with our orchards around here? The peaches are getting close to being done, right? The apricot harvest is done. The grapes are now being picked, and we talk about the grape crush is going on. That they're talking about going into maybe November or as late as December this year. So there's a lot of agricultural work going on right now. And when you're done with the harvest, what do you do to the peach trees, the almond trees? I'm sorry if you say almond, okay? But the almond trees, the peach trees, the grapevines, the walnut trees, what then happens?
Prune them back.
You prune them. How many of you prune trees?
I have orange tree. in my
About
back.
4 of us? That's it? Okay, you're going to have to help me out here in how fast we can prune. But let me tell you the story. My sister, some years back, had an apricot orchard in Tracy. And by the way, that just recently went into a subdivision. There are houses there now. But it was an apricot orchard, and she was needing to have it pruned. And they didn't have a lot of money. They had just managed to buy the orchard. So they were hoping family would help them. So we were out at Thanksgiving having dinner. And the issue is raised, would you be willing to help prune the apricot orchard? Now if you say apricot, it's all regional. Around here we just say the cots. But if you're willing to help prune, you've got time off. You know, those were the days when we had a Christmas break. So you had like 2 weeks between Christmas and New Year's, and so she wanted to know if I pruned trees for 2 weeks.
For 2 weeks.
It was rainy, muddy, cold, and if it wasn't raining, it was foggy. Apricot trees. Fortunately, they were young trees, relatively speaking. I need help. How long has it taken some of you, Travis, to prune a tree? How long? One tree. A long time. That was my response too. Take me forever for one tree. But could you quantify it? An hour, 2 hours, half hour? About an hour? Okay. Adrian? 45 to an hour for a tree? Trace, about the same?
Well, I have kids, so about 2 hours.
The comment, I've got kids, it'll take 2 hours, maybe more. If you're on a ladder, I understand that. Keeping the kids off the ladders. It's time consuming. Now, how many hours would you be willing to prune a day?
2.
Teresa says 2 hours. Travis? An hour. You're not, 1 hour's it.
Like 3 trees, I guess.
Maybe 3 trees. You're not going to get this orchard done very fast. I was saying, okay, daylight was at best at that time of the year what? We're talking November, Thanksgiving time. How many hours of daylight do you have?
To like 5 p.m.
You have about 7 a.m. It's light, and by about 5 it's getting dark. So I said 10 hours a day I can prune. I don't want to prune in the dark. You know, bring the headlights from the truck, put it at, high beam, and then you try to prune by truck light. Not wise. You understand that when you're pruning, you have to make decisions what to cut and what not to cut? I was talking with one of my colleagues just the last hour, and he said as a kid, his dad tried to teach him how to prune, and the idea is you cut suckers. Sucker means a limb that's grown that's not going to have any fruit on it for the next year. So you want to cut that off so your fruit wood's going to provide you the harvest. And so he had been cutting for some time, and his dad finally cut off a sucker and went whap with it. That's a sucker. And that, I think, is a very good object lesson. You know what they look like at that point, and you know you don't want those around. So you go ahead and start pruning. Well, this is the problem. We're going to go to the sideboard because this was an acreage, and Debbie, put that up on the screen. I said 45 minutes a tree, and that, keep in mind, is really pushing it. 45 minutes a tree. And let's add a new wrinkle to this problem. Let's say that you're willing to prune 10 hours per day. So 10 hours per day. And by the way, I can say per day or one day. It comes out the same. Now, if you've ever pruned 10 hours, the first day is not bad. Now, remember, you have to climb the ladder, then prune, then climb down the ladder, move the ladder in the mud, climb the ladder, and do this for 10 hours. A couple of falls, but it was muddy. So if you fall, you just wipe the mud off, get back up. But after about 3 days of this, you're ready to quit. But it's family. And so you say, okay. The comment, feed me well or I'm leaving. Yes, there was a feed me breakfast, bring me lunch, feed me dinner. And 45 minutes a tree. Now, they had about 30 rows of trees. And my recollection is about 20 trees per row. So this is about 600 trees that were involved. So this is the information. Now, I'm going to change my request here from how many hours, because that was depressing. We're going to take how many days to do this. So I'm just going to leave that there for a moment, and I'm going to erase what I have up here because, and I hope I took pictures. Anyway, I'm going to erase what I have up here because I'm going to have to start it in a different way. The question is, how many days is it going to take? And as we slide over, there's certain things I know. So for example, I know 60 minutes and 1 hour. Now that's called an equivalence. And we have to know some of those. And a lot of them we know from common sense. I also know that I'm going to consider 1 day of work as 10 hours, not as 24. I mean, I'm not going to prune 24 hours a day. So I'm going to prune 10 hours, and that's the equivalent of 1 day. Now, my question was how many days? And to do this with dimensional analysis, I start out with something with days, and this is what I have. 1 day is 10 hours. I want days at the end, so I am going to start with a fraction that has days on the top. That's the key to this. So a fraction with days on the top. So 1 day, 10 hours. Now that's what I want at the end. And I'm now going to multiply, and by the way, if you just look at this problem, thank you, that was very nice of you, Debbie. This is a question of how many days. Do you have any guess as to what it would be? If you just looked at that data, again, let's come back to the data for the information camera 1. Do you have any idea? Do you think you can get done with that in 2 weeks?
Probably like 10 trees a day.
Anybody?
If you're lucky.
You think you do it in 2 weeks, 7 days a week?
Depends how many people you have.
Me.
No.
Travis says it depends on how many people you have. I was the pruner. And I had 2 weeks break. Was I going to get done? It's a hard one just to look at and guess, right? Okay, let's come back. So I have 1 day over 10 hours. Now here's my goal. To multiply by another fraction that will allow me to cancel the hours that are here. Okay? So I have hours I want to cancel and be left with days. So back to my information. What do I have with hours besides the 10-hour day? Nothing. But what do I know? Back to here. That 60 minutes is 1 hour, right? So I could put 1 hour here and 60 minutes here, and I now can do what? Cancel the hours. But now what have I introduced? I've introduced minutes. Let's go back to the problem. Is there anything with minutes I can use? I have 45 minutes per tree, correct? So as I come off there, what does the per tree mean? The same as 1 tree. So 45 minutes for 1 tree. The minutes cancel. Okay, continuing. I need something with trees. What do I have? 20 trees in a row, per row. So 20 trees, 1 row. The trees cancel. This is called deforestation. Now I need rows. How many rows do I have? 30 rows. And that is by itself, I can just consider it over 1. Now, everything canceled as dimensions. Now, I consider the hours, the minutes, the trees, the rows, dimensions, just like feet, yards, inches that we did in the last unit. So let's look at the numbers that are left. So I have 1 times 1 times 45 times 20 times 30 over what? 10, 60, 1, 1, 1. I love those ones. And you must remember at the end, it's what? At the end of the day. I have days at the end.
So the hours and the minutes cancel, but not the numbers?
Just the units cancel. That's the dimensional part. That's the dimensional analysis. And if your dimensions cancel and you're left with the one thing you want, you know you've done it right. Now what can we do? Cancel the ones. Not the ones. What do I want to cancel? You can do better than that. What do you want to cancel? The what now? Okay, well, how about the 30 and the 60? If I cancel those, 30 into here is once, and into here is 2, correct? Now what? Okay, the 10 with the 20, and then what? The 2's, agreed? What do I have left? I need to take a leave from the college for a month and a half. Now, when should the pruning be done? Well, certainly before the next hot spell. So 45 days isn't bad if I had the time, but I only had 2 weeks. Translates less than 15 days. So my sister needed to find 3 of me, or find somebody that can prune a whole lot faster than I could. If you can find somebody who can prune the tree in 15 minutes, the whole tree in 15 minutes, then you'd have it. You mean do it all night?
No, get an
Electric saw, you think maybe saws would do it. Now you want pruning shears to get nice clean cuts. Okay, but do you see the problem? It's a realistic problem. So it was a problem if my sister didn't get more help. Okay, and so that was a rough year. I didn't end up doing 2 solid weeks of pruning. I helped, but not that much. Okay, new problem. Let me set up this scenario. And this is one that you may not have done to your folks, but my son did. And maybe you have brothers or sisters or your own children who have done this, but it amounts to this. It is Sunday evening, 10 o'clock at night, and this young son of mine comes up and says, "Dad, I need your help. I've got a paper due in the morning, about 8:30 in the morning. Could you type it while I do my other work? I've got it written now. Could you help type it while I do the other homework so I can be ready for tomorrow?" Now, the next thing usually is a lecture from me that says about responsibility, accountability, and that this is not a wise idea, and try to make him feel very guilty. And then say, well, could I manage to get it? Well, here is the problem. How fast do you type? Now, I've done a lot of writing and publishing, and I've done some typing in the process, but my typing is not all that fast. What's a good typist do if they're going to get hired? Anybody? 100? Wow. No, I know it can be done. Just, but what if you wanted to hire somebody? What would you consider sort of a minimum? 50 to 70 maybe, somewhere around 60, and then you'll hire them. I don't type that fast these days. About 30 words a minute, about half speed. Okay? And that's not without errors, but about 30 words a minute. So here is the structure. Let's slide over. Here was the problem. I typed 30 words per minute, and he would have written longhand. That created a problem too, because I had to read his writing. But about 50 lines on a page, and he had about 20 words per line, and it was a 10-page paper. And here was something I had to answer for him. Could I get it done in the amount of time I was willing to stay up that night, so he could have it at 8:30 and I could still get some sleep? You understand the dilemma? Now I've got the solution up here, and we're going to look at it, but I'm going to, again, if we'll just focus there, Debbie, I'm going to go ahead and so we can just set this up one more time and work it through. Okay. So the question, as we work this through, what do I want at the end? Hours, correct? So I'll just slide over here. I want hours. I need something with hours in it, and as I look at what I have in this list, I have minutes, but I don't have hours. But I know that 1 hour is what? 60 minutes. So I'm going to start with the first fraction and write 1 hour over 60 minutes. Now I know I want minutes in it because I have to do what? Get rid of this number of minutes. So we can slide over maybe and cut that much to there. Just slide over a bit. That helps a little bit more. Just really trim it tight. There we go. What can I multiply times this first fraction that will get rid of the minutes that's in here? Anything with minutes in here? The 30 words per minute is like saying 30 words in 1 minute. So we just say 30 words per minute, meaning 1 minute. Now, if that doesn't look like minute to you, we'll do that. But you get the idea? So I'm going to put 1 minute. I turn that upside down and say that's the equivalent of 30 words. So I've used that one. And I could check it off and say, okay, I used it. Now I need to get rid of what? The minutes. I've done that. What do I want next? Something that'll get rid of WDS, words. That's my abbreviation. And I can see from the look in the camera that I need to make those letters a little bit larger. God darn, words, WDS. Does that read better? Yes. What do I have from here? We'll just slide back and forth. Oh, good. We won't. 20 words in a line, right? So back over here, I've got 20 words over 1 line. The words cancel. Okay, the other camera. I need something with lines, correct? Do I have anything here with lines?
No.
I don't? I've used this one, but I can use what? The 50 lines. So new fraction, 50 lines over what? 1 page. The lines cancel. And finally, what? A 10-page paper. So I'm going to come over here and write 10 PG for page over 1. The pages cancel. Now the point here is when I start with this first fraction, it tells me everything else that I need here. Now one of my colleagues who worked with me in this program for a number of years, and I owe a lot of the credit to the success of what we've done to his participation. That was Darrell Top. And Darrell had a phrase I really liked here, and we'll give credit to him for it. He said, once you've got this, let the good times roll. Because if you get this first fraction, it dictates every other fraction. So at the end, all you have is hours. Okay, so let's see if I am going to be amenable. if I'm going to be friendly about doing this typing that my young son has asked. So I have a 1, and a 1, and a 20, and a 50, and a 10. Folks, when all these numbers come up here, it's not looking good, is it? That's looking very depressing. Okay, a 60, a 30, and you have to love these ones. And this is going to be in what? At the end, I wanted what? How many hours? And I've got to make sure I do that. So this is number of hours. Okay, could you just multiply everything in the numerator and then multiply everything in the denominator and just divide with the calculator? You could. But let's see if we can at least have some fun with it. Now, again, I don't always have the same idea of fun you do. But working with numbers like this, sort of neat on a Wednesday morning. Okay, what are you going to cancel?
The 2 and the 6, 20 and the 60.
The 20 and the 60 makes sense?
Ones and 3.
Okay, so once here and 3 here. What else would you be canceling?
The 10 and the 30.
Okay, I'll go with the 10 and the 30. Anything else I can do? Nope. So what do I have left in the numerator? A 50. And what do I have in the denominator? A 9. And this is what? The number of hours. Will you give that to me as a mixed number, please?
5 and 5 and
Do you agree with Teresa's statement? 5 and 5/9. Now, you understand you are going to stare at the wall a few times, and you may decide to get the 13th cup of coffee and then hit the restroom. 6 hours? Easily. So if this starts at 10 o'clock at night, when can I anticipate going to bed? 4 a.m. Yes, so I get up at 4 or earlier so you don't go to bed at all. So what then follows? I'm not sure what's an appropriate response at that point. So you suggest that maybe, what is it going to cost you if you're late? How many points do you lose? What if we only do half the paper?
What if you did it Friday instead of Sunday?
Novel concept, I'm being asked. What if you said, what about maybe if you'd done this Friday night? But understand, it is now Sunday night. And that's certainly a lecture that's deserved, but reality is it's not going to happen. I don't know the moral to this story other than you have choices. You don't type it, and your youngster gets hurt academically. You do type it, and you reinforce a behavior that says, I'll do, sort of bail you out. I'm not sure if there's a halfway point where you say, okay, I'll take this into the teacher and say, I'm halfway done, could I have an extension? Okay. If you'd thought earlier, what could you have done? Called a typing service and paid money to get it done. Or you call up relatives and say, would you be able to type 2 pages? And I'll type 2 pages, but then must have the same fonts and so on. By the way, just to put this in perspective, this process of typing is so much easier now with word processors and computers because they have spell correctors and you don't have to make corrections on it. Much easier. Okay, so life is much better. When I was doing this problem, unfortunately, we were still doing things with an electric typewriter with correcting tape and whiteout. And if you weren't allowed correcto tape and the whiteout, you retyped the page. Okay, and there were a lot of manuscripts I did that had to be camera-ready copy, which means no tape or whiteout, and if you have one error, you retype the page. And so sometimes it took 1 page 3 hours. At 10 pages, 30 hours. So it was really a bear. Well, that's the kind of problem we're talking about. We'll leave that on the board. And what I'm going to ask that you do as you work these problems is try some of them just to see if you can set them up. I'm going to, and a lot of these problems relate to things that I've been involved with. Just to illustrate, the 9th problem on page 73. Now, in this case, it's something I've considered. I haven't actually done it. One of my colleagues did this, but wants to take a ride from here to New York. And it's roughly 3,000 miles. And in this ride, it's during the summer. And so you have about 12 hours a day. Now just picture yourself on a bicycle riding 12 hours a day. You'll be sore. That's putting it mildly. Sore, tired, hungry. How many weeks would it take you to go from here to New York, and how fast would you be able to average? Now, I try to ride on a daily basis. There are a few days with rain and such, but as we go to the book now, 10 miles per hour is it's not what we would consider as fast as somebody doing the Tour de France or somebody who's racing in our race that we have here in the summer in Modesto. I mean, those race speeds get up to what? 30 miles per hour, 40 miles per hour, and if you're going downhill, you can get up to 50, 60 miles per hour. I've done that, and it's scary as heck. But if you're riding just long term, 10 miles per hour, so here's the problem. You're going to go 10 miles per hour, you're going to ride 12 hours per day, you have 7 days a week. How far to go from here to New York if it's 3,000 miles? Now the point is, that problem is a very typical problem that you would be interested in if you want to be able to do that during summer break and you have a few weeks off. There are problems in here about children asking for donations. You know, I'm going to be going around the track, and for every time I go around the track at the high school, will you give me 10 cents? Or my sister had fundraising activities, and my daughter was involved in a business where they went bowling, and how many pins would she knock down during the morning bowling on a Saturday? And would you give me 10 cents per pin? Okay? And bowling for dimes. And you have to be careful. So these problems are like that. Here's what I want you to do. Try to pick some problems, and maybe the 9th one here was a good one. Number 10, 9 and 10, and there's a whole supplementary set. And pick a few problems and see if you can be successful in the process. So page 73 is a good one, and then page 78 and 79. There are 7 more problems there. Just pick a few. See if you can set them up, and we'll answer questions and to try to spend more time on this tomorrow.